grade math again this year?
Yeah.
Sorry about that.
At least you get it out of the way.
Yep, that's true.
If you guys are new to this class, I will always have handouts up here, so if you forgot them, come grab one of each.
Good morning, Bateville High School. It is Thursday, August 22nd, 2024. Will you please join me for a minute of silence?
Put that up now.
Thank you very much. Will you please stand for the pledge? For which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, welcome back. This morning, I need you to start off, so as you guys come in, you need to look there at the bell work. There's two assignments we worked on last class that we need to spend some more time on, which would be number 3 and number 4. So again, those should already be numbered in your binder. So open your binder, go to those. Maybe get them out of your binder if you don't want to leave them out all day. And then 2 of the handouts you picked up this morning need to be numbered. I wasn't able to number those before I copied them. So one of them is it's called 1.16 Intermediate Value Theorem, IVT. That's going to be number 7. We'll do just some of that today. The other one you picked up is number 5. Again, it is important that you number them correctly so that you know what I'm talking about, especially when I'm asking you to turn in stuff. Okay, so very quickly, I wanted to give an opportunity to maybe ask a question or two from assignment 3 before I have you turn that in. Specifically the back page, because some of those AP questions on that one you didn't finish in class, and I think most of those were good, fair questions. So if you were not sure if it was a good, fair question, and you're not sure if you would be comfortable with seeing it on our first quiz, then I need you to ask. So,
on the last page, problem 3.
problem 3. Okay, so that specifically was the one that I was expecting most of you guys not to know. So I'm going to go ahead and record this one real quick so I can put it on our website. So bear with me there. But the one nice thing is, so all of these are actual AP questions on this last page, 1 through 4 here. But some of the AP exam changes over time. So luckily, this thing that's called the greatest integer function, I still want you to know it. I still want you to have it correct on your worksheet here, which is why I'm willing to take the question. But luckily, they have not asked about this in a long time. So you don't need to study this greatest integer function for this class, because I don't expect you to see it on the AP exam. But the greatest integer function looks like this. They're doing it over here. And it's kind of a weird way to round. It's where you always round down. So numbers from 0 to 1, round down to 0. Numbers from 1 to 2, round down to 1. X values between 2 and 3, round down to 2. And then going this way as well. So this is also sometimes called the step function because it kind of looks like steps. So to work this question, you were trying to determine the limit as x approaches 2 from the left, and you have a 2 on top. The constant stays a constant. And then this greatest integer, what is it approaching as x approaches 0 from the left? What is it approaching as x approaches 0 from the left?
0. -1.
Right here, yeah, -1.
Oh.
The closer you get to 0 from the left, the closer it gets to -1. So that's where the denominator becomes -1, which is why the answer to that is -2. So, not a terribly, it's not that much harder than the other questions, but again, you probably just don't know this function, but you don't have to study it for the AP exam. But I do expect you to have it correct on your worksheets because we went over it and gave you a chance to ask questions. Okay, is there another one of these questions on the back page, 1, 2, or 4, that you thought was harder than the others? Okay, and then I would take one question from any other part, something else that you thought was harder than the others. Okay, I have to trust that you guys are going to ask when you need that. So please make sure there's a number 3 on that. I think it should be. Make sure your name is on it. Oh, I have no idea. I don't. Yes. Okay, Brian, you need to go to phase 2 first floor office. Okay, make sure your name is on that, and then if you guys would just pass it down this direction, and I'll collect them all at once. Most of the time I ask you to turn something in, I'll just have you come turn it in at the start of class or before class. But just for convenience here, let's just throw them down. Make sure your name is on it. Now, even if somehow you forgot to finish this, you should still give me what you have. Remember, incomplete work is half credit, but you could come back after I give you half credit, you could finish it, turn it back in before the test. Okay, here, you gotta sort through. You could take half credit today, finish it before the test, and still get half of your points back. If you don't give me what you have today, and you just turn it in completed before the test, then you only get half credit. So you end up with more credit long term. So you should always give me what you got. What's on there? Okay. So I'll give those back to you shortly. And again, this one is just a participation grade. So what I'm going to do is spend about 10 seconds, flip through. I know which parts we did together. I can quickly see if it looks like you participated. I can see if you did the rest of it. If I notice that you didn't check your answers or make corrections or something, I might note that on there. But basically, you'll get 100 if it looks like you tried it all. So, and had your work there. So, not a lot of pressure. Okay, so we need to talk about what we did last time and understand how this is moving forward. So, the assignment you just gave me, we talked about what a limit was, how to think about a limit from a graph, the difference between a limit and a one-sided limit, when a limit could not exist, and then trying to get used to some notation stuff. Now, on number 4, this is one that we started talking about last class, but we didn't get very far into it. I just wanted your brain to start thinking about it. Okay, I have to look at my glasses. Let's look at this one. Okay, so when we don't have a graph and instead we have a function like x squared plus 2x minus 4 or y equals 6 or y equals 4x squared minus 5x over x, instead we have the function. We had this process we talked about. You should always start with direct substitution first. So you're just going to plug this value in here, and if you get a real number, you can assume that's your answer. Try to plug it in, know where to plug in. 6 is what you got, 6 is your answer. Where we have to do a little bit more work and where I want you to practice for 10 or 15 minutes here in a moment is specifically when we get 0 over 0. 0 divided by any other number is 0. Any other number divided by 0 is undefined, but 0 over 0 can be anything. So we actually have to put some thought into it. So before I show you the other ways to deal with 0 over 0, I want you to practice the direct substitution / factoring on the next page. So we also crossed off these special limits. I don't expect you to know these at the beginning of the year. It's a waste of your time. I can show you a better approach in about a month. So we crossed off that. We crossed off 6, 7, and 8. And there's one or two, if I need to look at my copy. There's a couple others of those that are squeezed in, so let me tell you which those are so you can put an X there. I don't want you to waste your time on those. Okay, so put an X on 5 and 6 on that page, and last page, don't worry about 23, 25, or 27. Again, nothing wrong with those questions. You should be able to do those questions eventually, but they're just not our focus today. So let me say that one more time so you can put an X there and not waste any time on them. On the back page, 5 and 6, you're not going to know how to do. And on the last page, 23, 25, 27, you won't know how to do. Okay. But let me do two examples with you. So I'll do just a little bit more of a refresher here. And those of you that took pre-cal last year, again, you probably don't even need this, but just to give a couple more examples about what we talked about last time. Okay, so always, 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 no matter what the question looks like, no matter what you think it's going to want you to do, you have to train yourself to just do direct substitution first. Try to plug in the value you're approaching into the function. And if you've got some arithmetic, do the arithmetic. And if you come up with a real answer, basically anything besides 0 over 0, you can assume that's your answer. So, direct substitution questions should take you about that long, 5-10 seconds. I mean, be careful with the arithmetic, I guess, but. Okay, the only other type of question you're going to see on this worksheet, I've got to jump down a little bit to about question 9. So, one more example. Now, to plug in -7 into this, and so I'm doing direct substitution, and I'm trying to do this without a calculator. There's no reason this needs a calculator, so you shouldn't assume you're getting a calculator on this, on our test. But to be fair, the arithmetic's kind of hard. 2 times -7 cubed plus 11 times -7 squared minus 21 times -7. I can't begin to do that in my head. So what I would do is go ahead and factor. So even though I haven't done direct substitution once, I'll show you how factoring makes this arithmetic easier. So the bottom is just GCF. GCF should be quick for you. The top is a GCF. And a trinomial. That one's going to take you a little bit longer, but accuracy is more important than speed here. If you need to slow down and spend a minute to factor this correctly, then do so. Okay, so normally I would say don't factor anything until you're sure it's direct substitution, but again on this one, I just can't do that in my head. And if I have a calculator, I have other ways to go about getting this answer anyway. If I have a calculator, I don't think this is the most efficient way to do it, but I could graph this function, look at the graph, and then see what it approaches from the left and the right as x approaches -7, just like we did on handout number 3. Okay, so now that I've got it factored, now if I try direct substitution, is it going to give me 0 over 0 or something else?
Something else. 0 over 0.
Okay, so notice if you plug in -7 here, this goes to 0, right? And 0 times anything is going to be 0. So even though I don't know what this is, I don't care. 0 times anything is 0. 0 times anything is 0. So this in fact did head to 0 over 0, which is not an answer. But this is what we call indeterminate form. Indeterminate form is the one that's a pain where we have to do more work. Direct substitution's fast and quick. 0 over 0, we have to put a lot of thought into it. But on this specific worksheet, you're only worried about factor, cancel, and then do direct substitution again. So plug -7 into what's left over, not the canceled out stuff. And this would give me -7 times -14 minus 3 would be -17 over -7. So those are going to cancel anyway and end up with -17. So one thing I'm going to point out a lot the first 3-4 months of school, probably till you're sick of hearing it, but what you really need to understand here, and you're going to really believe me as time goes on, but the hardest part of calculus is not usually calculus. Understand, for this particular question, it helps if you know what you're finding, if you understand what a limit's trying to produce, although I didn't really need that to get this answer particularly. Direct substitution just means plug it in and do the arithmetic. That's not really calculus. This was kind of a pain in doing the factoring, but factoring is not calculus. So really the calculus to this question is understanding that you should start with direct substitution. If you get 0 over 0, try to factor and cancel, and then finish with direct substitution. It's understanding that process, but the actual legwork, the actual steps on your paper tend to be past stuff, like factoring and arithmetic and canceling out, reducing fractions. And that's pretty consistent through most of calculus. Calculus concepts are not that difficult, but the algebra behind them can be very difficult. Okay, so I want you to have a few minutes to practice some of these. So unless you worked ahead last time, which some of you did, and I never have an issue with that because it just makes your next class a little bit easier. But go ahead and start with number 2. Try number 2 before you try number 3. Try number 3 before you try number 4. Please try them in order because I will give you a chance to ask a few questions, and I just want to make sure everyone's tried 2 before anyone asks about 2. And I want everyone to try question 3 before someone asks about question 3. So let me give you a bit of time here. Again, I'm thinking about probably about 15 minutes. Take a question or 2, and then if you're finished with it, great, and if you're not finished with it, then you can do the last couple for homework to get caught back up. I'm going to grade these homeworks real quick, or try to do it quickly, and I will try to get those back to you today. Okay, before I start passing back the homeworks, give you guys a chance to ask a question or two. That way if something's holding you back, you can still be making some progress with your last 5 minutes here. Anything I can help with so far? Yeah.
Number 18, I'm not really sure.
Okay. So if you have not looked at 18 yet, you've got some options here. You can either jump to 18 and go back to what you're doing in a few minutes, or I will record it and put it on the class website, and you can watch that when you get to it outside of class. So. Okay, so limit question. I don't know what the graph looks like, so we can't do what we did last class. I need to start off with direct substitution, and this one's going to be kind of hard for me to do in my head, but I know this is 1 minus, I'm plugging in a half for x, minus 2 times 1/2 squared. So 1/2 times 1/2 would be 1/4. So 2 times 1/4 would be 1/2, and then 1 minus 1/2 goes to 0. So are you okay with why that goes to 0? Hello? You have to say it again. Yeah. Sure. Wait, where are you this year? 3rd floor, phase 2. Okay. Okay, yep. Ellen, after class you need to see Mr. Champion. He's in 3rd floor, phase 2. Okay, so the numerator was a little difficult to figure out that it goes to 0. The denominator is a little bit easier. 2 times 1/2 would be 1, minus 1 goes to 0. So, unfortunately, I say unfortunate because 0 over 0 is the only ones you have to buckle down and do a little bit more work on. And right now, until we get to the next handout, the only thing that you have to worry about is factoring. Truthfully, for this class though, anything algebra-like is fair game for this. So, the denominator doesn't factor. It's just 2x minus 1, not even a GCF. But the numerator, what I did is I rearranged these. I did this out to the side. I like it to be descending. Biggest exponent first, next biggest exponent, last biggest exponent. Also, this is completely optional, but a lot of times when you guys are factoring, if this a is negative, that seems to make it harder for you. So if that's the case, just factor that out as a GCF and then leave it out front, and then you don't have to worry about it anymore. You don't have to mentally juggle it. So this ends up factoring as a negative, a 2x minus 1, and an x plus 1. Okay with that? So yeah, so just rearranging it, maybe factoring out the negative, might make the factoring a little bit easier. Okay, now that they're both factored, something should cancel. If they were going to 0 over 0, then you should have the same factor in the numerator and the denominator. And now you finish with direct substitution. The numerator has a negative 1/2 plus 1. The denominator all went away. Does that mean the denominator is 0? No, that means the denominator is a 1, right? 4 over 2 doesn't become 2 over 0. It becomes 2, or 2 over 1. So, negative 1.5, or negative 3 over 2. That's what I would aim for. Anybody else want to ask a follow-up to that one? Okay. Another question or two? Any that you thought were harder than others? Ellen?
How do you do 19?
19? Okay, so 19 is unit circle. If you guys skipped pre-cal and you don't know the unit circle, you need to start doing that immediately. The unit circle is common and fair game for calculus. So for question 19, you still start off with direct if you get 0 over 0, you need to worry about factoring. If you get anything else, it's going to be your answer. But to do this, you have to know the unit circle. You have to know all of the radian values around the unit circle. Calculus doesn't use degrees, you're only on the hook for radians. So you have to remember where pi lands on the unit circle. You have to know the points from the unit circle. You need to know that cosine is the x value, sine's the y value, and know how to divide those to get tangent if you needed them, and how to take the reciprocal of those three to get the other 6 trig functions. So the cosine at pi is -1. One of the easier questions, but it's 100% reliant on you knowing the unit circle. And even those of you that did pre-cal last year and did the unit circle, you know we do the unit circle a lot more first semester, and you've had summer break, so you're going to be rusty, but unit circle is a big part of calculus, so you need to refresh on that. Okay, somebody else? 1, 2 more tops? Yeah.
Page 21.
Sure. Okay, so direct substitution. I can see the denominator goes to 0. Numerator goes to 4 plus 24 minus 16. 4 plus 24 minus 16. And that is 0 also. So my only tool at this point until just a couple minutes from now is factoring. Doesn't look like the denominator factors, but the numerator factors, we could do a +8 and a -2. So I'm going to guess this is about how far you got, and then you got stuck. Is that the problem? So do you see how these two are almost the same thing? This is a positive x, -2, positive 2, negative x. So if these need to be canceled out, but they have the exact opposite signs, just factor a negative out of one of those. So like if I factor a negative out of this, like a GCF, it's going to switch the signs so that when I distribute it, it goes back to the 2 minus x that it's supposed to be. But now these signs match up. Just don't lose this in your answer. And you would be left with -2 plus 8, which is -10. So I think you have to factor that negative out a couple times on a few of these. So if that's not something you thought of, you might emphasize that in your notes. So if you get stuck on that, you can move forward. Okay, so this is one of the things that I will ask you to finish up for homework if you didn't finish up. So if you were not done, you should be pretty close to done. And this is, since we did not have school on Monday, tomorrow is an A day, so I will not see you guys again till Tuesday. So this is one of the 2 things I will ask that you finish up and spend some more time on and think about outside of class and have ready to turn in. Okay, next up, we need to move forward. So we recapped a little bit of what we did last class. We practiced a little bit more of what we talked about last class. But now we need to start thinking about some new calculus. So on number 5, we're going to talk about how to deal with 0 over 0 in ways other than factoring. Factoring is just the most common type, but it's not the only type they will ask you to do. So this is one of today's handouts. Number 5. Okay, and I did not get to number this one for you, so you need to number it as number 5, please. Okay, so the first part is just going to go very quickly, because the first part's just a recap of what we talked about last time. If you're trying to find the limit and you have the function instead of the graph, start off with direct substitution. If you get a real number, you are done. Don't overcomplicate it. If you try direct substitution and you get a number other than 0 over 0, what is that always going to give you? Okay. So we would say this is undefined, or usually with limits we say they don't exist. That's not 0 over 0, so don't overcomplicate it. Okay, based on what we talked about last time and practiced just a second ago, sometimes you plug it in and you get 0 over 0. And your first thought, before you try anything else, is how does this stuff factor? So the numerator here is the difference of two squares, x minus 4, x plus 4. The x minus 4's then cancel. And once you get something to cancel, direct substitution should be fine then. Your answer comes from plugging in 4 into x plus 4. Honestly, that type of question should be directly related to how good you are at factoring. If you are not good at factoring, you're going to think those questions are tough. If you're good at factoring, you'll probably think those questions are easy. But once again, factoring is the most common way to deal with it, but any algebra thing is fair game. So once again, that's basically the same question type. We'll skip that. So always try factoring first when you've got 0 over 0, just because it's the most common and easiest. And I'm going to talk about this little flow chart for, I don't know, 30 seconds, basically. I just felt like this was kind of a good representation of a visual of what we're about to talk about. So the part you already know is this. You start with direct substitution. If you get a number over 0, you can say it's does not exist. It's going to give you an asymptote. If you get a number, you can assume that's your answer. But if you get 0 over 0, indeterminate form, you've got to do more work. The more work could be something like factoring. We've already talked about this path. But it might be something like conjugates, or trig identities, or complex fractions, or anything algebra. But these are some of the common ones. So we do that work, we get something to cancel, and then as soon as something cancels, it tells us go all the way back up here and try direct substitution a second time. So if this helps, great. If it doesn't help, there's nothing you need to do here. I just thought the visual might help some of you guys. Okay, so on to the back page. This is a sampling of other question types. So some of these are going to be 0 over 0, some of them are not. This question 1 is what we did last class, but this is in table format. So I'm going to actually ask you to practice this in a Khan Academy assignment here after we're done with this handout. So to me, this is no different than having a graph, but you guys don't practice reading tables quite as much. But what we physically did last class is if we wanted to know the limit as x approaches -2, we would think about the y value it approaches on the left, the y value as it approaches from the right, and what y value does it look like it's trying to reach from the left and the right.
8.
Right. 8 is a reasonable estimate. Now we don't really know. It could be 8.01, but 8 is a good reasonable estimate. The limit from the left has to equal the limit from the right. I guess your other option is you could literally plot all 6 of these points and then try to do it that way. Okay, number 2, so limit from a piecewise function. So you've got to think about, just like with the graph, you need to be looking at the right part. As x approaches -5. So I want to know, how does it approach -5 from the left? So I would want numbers just a tiny bit less than -5, and -5 from the right. So I want numbers a tiny bit bigger than -5. You need to understand for this one that means you shouldn't use this at all. Numbers around -5 are nowhere between 0 and 10. So you're going to plug this in here for the left limit, and you would plug it in to the same thing for the right limit, because they're both when x is slightly bigger and less than -5. And then your answer will come from that, and that would be 0. That's another unit circle question. So I'm saying the same thing. You got to check the limit from the left versus the limit from the right. But sometimes you've got a graph to do that, sometimes you've got a table to do that, and sometimes you need to plug that information, direct substitution, into a piecewise function. Okay, this one may not have printed off great, so make sure you show that this is from the left. This one's the limit as x approaches 3 from the left. So notice you've got to be very careful about which one of these to plug it into. This is saying when x is bigger than 3, so that's not going to be to the left of 3. To the left of 3 is less than 3, like on a number line. This is the one where x is equal to 3 or less than 3. So that's how I know to plug it into the top one, not the bottom one. Now notice I'm just plugging in 3 because I'm approaching that. So I'm approaching a number that gets to 3. So it's so close to 3 that it's basically the same thing. Okay, question 4 wants to know x approaches -4 just from the right. Again, I don't know if that copies off well. Oftentimes these don't. So before I say it, I want you to put 10 seconds of thought. You should either be plugging it into the top one or the bottom one, but not both. So I want you to think about which one it should go into. Okay, so for this one, you should have plugged it into the bottom. From the right is when it's a little bit bigger, and this is saying when x is bigger than -4. So your answer could be this. When we do free responses, you don't have to simplify any arithmetic, so you're welcome to stop there. Now, to be fair, on a multiple choice, this probably would do a little bit of work here. You have to remember that 2 to the -4 is the same thing as 1 over 2 to the +4. And 2 times 2 times 2 times 2 is 16. So 1/16 is how that answer would look as a multiple choice question. Okay, question 5. The limit x approaches -3. So if I wanted to know the limit as x approaches -3 from the left, I would plug that into the one where x can be less than -3, and I would get 2 square root of 4. Mentally, I'm thinking about what is it as it approaches -3 from the right. So from the right is a number bigger than -3, so that's what this is saying. So I would plug that in here, and I get 4. And if the limit from the left is 2 and the limit from the right is 4, what does the limit equal?
Does not exist.
Very good. Those have to be the same. Now, you've got to be very careful with piecewise functions. There's not a just plug it into both and see if they're the same. I'm trying to give you a good variety of questions here. Question 2, I only plugged it into the top one because it's the only one that made sense based on the restrictions. On question 3, I only plugged it into the top because it wanted the left limit. Question 4, I only plugged it into the bottom one because it wanted the right limit. Question 5 wanted both. I needed the left and right limit, and based on how this piecewise function was split up, I have to do that. Okay, so that's kind of random. I will try to give you some more of that. I don't think piecewise functions are hard to deal with, but I know I've had a little more practice with them. But this is where we're getting to. This is a real important one. Okay, so this is not a piecewise function. I don't have a graph. I don't have a table. I know I have direct substitution. I still should always do direct substitution first. So I do that. I see the numerator goes to 0. The denominator goes to 1 minus the square root of 6 minus 5, which also goes to 0. So we've got the same problem, 0 over 0. So your first inclination should be, well, I'll just factor these. Factoring worked on the last handout. It's probably going to work here, except the numerator doesn't factor and the denominator doesn't factor. I would still try that first because that's the most likely thing. So another algebra trick that you have to know for these question types. And how I know this is this question type is because of this radical here. I would like to multiply this fraction by 1 because multiplying something by 1 does not change its size. But I want a very specific one. I want one that's the conjugate of the denominator. So conjugate just means you switch this middle sign. So I've got to do 1 plus the square root of 3x minus 5 over 1 plus the square root of 3x minus 5. This is equal to 1 because anything divided by itself is 1. Multiplying by 1 doesn't change the size. And just to emphasize again, conjugate means you switch only the middle sign between the two terms. Everything else stays the same. Now the conjugate could come from the numerator too. If the square root stuff was in the numerator, I would want the conjugate of the numerator instead of the conjugate of the denominator. Okay, now what I'm going to do is multiply these two fractions together. So here I've got an x minus 2 times a 1 plus the square root of 3x minus 5. Don't bother distributing that. Just leave it that those two are being multiplied. You multiply fractions, you multiply your numerators to get your numerator, you multiply your denominators to get your denominators. But here's where this is going to shine. This is why this process is so useful in mathematics. When I multiply something by its conjugate, I could do the first part of FOIL and get 1. I could do the outer part of FOIL and get positive square root of 3x minus 5. I can do the inner part of FOIL and get a minus square root of 3x minus 5. And then the last two. A positive times a negative is a negative, parentheses. Square root of 3x minus 5 times square root of 3x minus 5 is going to be 3x minus 5. And the beauty of this is anytime you multiply something by its conjugate, I usually don't do this step, the outer and inner part of FOIL will always cancel, and the rest of the stuff simplifies pretty nicely. 1 plus 5 and a negative 3x. So foiling 1 minus the square root of 3x minus 5 by its conjugate seems like it would be a disaster, but it's actually not too bad if you're careful with your work. Okay, that's the hard part. You got to recognize the question type. You got to know this strategy helps sometimes, this multiplying by the conjugates. Once you do that though, you should be very close to the final answer. In fact, notice in my denominator, if I factor out a negative 3, then I get something to cancel. And just like the factoring questions, the second you get something to cancel, direct substitution is ready to get plugged in and to get your answer. So that would be 2. Negative 2/3. So let me bug you again. This question, you guys have heard of conjugates before, correct? Well, I know if you did pre-cal last year, you did questions like these. You've heard of conjugates. You probably haven't used conjugates a lot except for pre-calculus. Knowing when to use it, knowing how to multiply the square root of something by the square root of something, FOIL, remembering how to multiply fractions, factoring out a GCF, all past stuff. Not really calculus, but it all piles up, and if you don't remember how to do one of those things, then it keeps you from getting this one correct. So, okay, let's zip through the other questions pretty quickly here because I want to focus on 10 and 11. Those are a little more interesting, but okay. So 7's just another piecewise function. I'd like to know the limit as x approaches negative 1. So once again, take 10 seconds. I want you to think about, am I going to plug negative 1 into this top function, bottom function, or both? So just to yourself, just mentally commit to top, bottom, or both. Okay, this one needs to be both, because this one is when x is less than -1, so this would actually be the left limit. And you need to plug it into this one, because this is when x is bigger than -1, so that would be the limit from the right. It looks like I get an answer, well, if my arithmetic was correct. The left limit is -1, the right limit is -1, so the limit is -1. Limit from the left is the same as the limit from the right. Just make sure you're careful with those inequality signs. Okay, we've already done a question like number 8, but again, it's fine. It's the beginning of the year. It doesn't hurt for you to keep hearing this stuff. So, direct substitution, 0 over 0. First major strategy is factoring. If the numerator factors, that's probably the path that you should take. Now, if you only factor this,
Take out x squared.
thank you, x squared. Okay, so how did I know, if you noticed me hesitating there, how did I know that I had done something wrong?
Because they ain't canceling them.
Right, I knew something was supposed to cancel. So either I just was wrong about what kind of question it was, or I didn't factor it correctly. And so that's kind of nice that you have something to go back and check. Okay, now that it's factored correctly, stuff cancels, direct substitution gives you your answer. Looks like 2. Just another factor question. Okay, number 9, I can tell this is not going to be 0 over 0, so it's obviously just direct substitution. 8 minus 5 times 4 plus 1, negative 11. Okay, let's get down to question 12. Let's take care of the other easy one. Direct substitution, you plug in 2, you get 4 over 0. 4 over 0 is not indeterminate form. Any number other than 0 divided by 0 does not exist. Only 0 over 0 should you be spending more time on the questions. Okay, let's go back to 10 and 11. So I don't have a lot of practice for you on these question types, but I need you to know that they exist and so that you have an idea of the strategy behind how to tackle these. So, same structure as all the other questions. You're going to try direct substitution. You're going to hope you get something other than 0 over 0. But if you get 0 over 0, think about factoring. Doesn't look like anything really factors. You can think about conjugates. This one doesn't have a conjugate because it doesn't have any square root stuff. So, this is just a different algebra type of question. We've got a different way to simplify this. So, I guess my first question would be, do you remember what it's called when you've got a fraction within a fraction like this? Small fractions within a bigger fraction. Very good. That's called complex fraction. The algebra you have to do is you have to remember how to simplify a complex fraction. And again, to be fair, this doesn't come up a lot in limits, but it is a topic that comes up throughout the year. So if you don't remember how to simplify complex fractions, you need to give a little extra attention here. So complex fractions, I would love to multiply this by 4 because it gets rid of a smaller denominator, but to do that, you just need to multiply all of the terms by 4. To get rid of this smaller denominator, I would love to multiply this by x squared because times x squared divided by x squared cancels out. But that's only okay if you multiply everything by x squared. So basically, you just multiply by all the small denominators and see what you get left over.
So 4x squared?
I'm sorry?
4x squared?
Yeah, so I multiplied everything by 4, and then I went through and multiplied everything by x squared. Or you could just do 4x squared from the beginning. That's fine too. And what's left behind is 12 minus 3x squared over 4x squared times x minus 2. So I'm not finished, but the unique part of this question is already done. Multiplying by all the small denominators changed it from a complex fraction, smaller fractions within a bigger fraction, into not a complex fraction. Now we could do GCF again. I'm going to switch these two. Factor out a -3, move this first. Factor completely. You get the the x minus 2's cancel. And so to finish, notice how sloppy my work is starting to get. If you're not careful, you're going to lose something. Plug in 2 into what's left, which would be -3 times x plus 2 over 4 times 2 squared. You end up with -3/4. This is the, if you did not remember before I said something about complex fractions, this is the part of your notes you need to emphasize. I multiplied everything by x squared because it did this, and then I multiplied everything by 4 because it did that. It canceled the smaller denominators away. And then again, I still had more work to do, but it was consistent with what we've already done. So those come up, not a lot, but sometimes. So when factoring doesn't work, when direct substitution doesn't work, and when it's not a conjugate question, if it's a complex fraction, you might want to try it that way. Okay, last one of these.
For a second, please.
Yep. What's your question?
No, that's it. Thank you.
Yep. Okay, so last one from here, just another example of a different strategy of how to simplify these. So we've got direct substitution, factoring, conjugates, and complex fractions as our tool belt now. So 11's the same idea. You try direct substitution, you've got to remember unit circle. If you get something other than 0 over 0, you're done. If you get 0 over 0, you need to try something else. Before I tell you what to do here in a second, what I would imagine you would do is you would try factoring, and you can factor out a GCF out of the denominator. And that's fine. In fact, I think we need to do that. But we don't get anything to cancel. Something has to cancel before direct substitution is going to work. You know that's your goal. So this is what I would call a trig identity question. You are not going to get anything to cancel until you realize that you might be able to make this look different. What is cosine squared equal to? Very good. 1 minus sine squared. That's the first of the 3 Pythagorean identities. In fact, that one's on your desk right now, I think. I think everybody has that one. The 3 Pythagorean identities. This is one they expect you to know. Now again, I'm not finished, but the unique part of this question is done. This could actually be factored more. It's the difference of 2 squares. Anytime you need factoring, you probably need to factor completely. And finally, that cancels. Then I can plug in my pi over 2. Okay, and you got to go back to unit circle again. The sign at pi over 2 is 1. You square that, you still get 1. So 3 times 3 over 2 times 2 would be 3. Again, I know I'm going over part of this question quickly, but I'm trying to focus on the important part. I still tried direct substitution. I still had to deal with 0 over 0. The other tools we've talked about didn't help. You know something still needs to cancel, like all of these questions. Eventually, something's got to click in your head where you say, I can change this to this. So of all of the trig stuff you've learned, hopefully in pre-cal, unit circle is certainly one of those. And, well, knowing tangent, sine over cosine is important. And these Pythagorean identities are pretty important too. There's not a ton of that trig stuff that you have to know to survive in calculus, but we did see a few of these today. So I just showed you some tools to consider when you get stuck. Okay, next up, so that one's completed, I believe. So number 6, if you get out your own piece of paper, you need some scratch paper, then I'm asking you to be number 6, and you'll need your Chromebook. So I have assigned you 2 Khan Academy assignments. Khan Academy assignments are usually 4 or 5 questions. One of them is finding limits from a table, so like what we did last class, but instead of a graph, it's a table, because I know more practice with tables is good. And one of them is dealing with 0 over 0 with conjugates. So we did one of those on your notes. You might want to leave that out, but I need you to practice that process so that you can do it if you're needed to. So, Khan Academy assignments are graded on accuracy, but the nice thing I like about these, other than y'all get different questions and such, is you can do it as many times as you want to until the due date. So this is going to be the second thing I ask you to finish up for homework. So if you start the one with tables, if you need to do it 10 times before you can get 4 questions in a row right, then do it 10 times. If that's what it takes for it to stick, then that's what you need to do. On the conjugate questions, same thing. If you've got to try them a couple times before you can get 4 in a row right, at the end of the day, it doesn't matter as long as you got those right. So in that sense, this one kind of has some retries to it. The other thing I like about Khan Academy, we use Khan Academy a little bit more at the beginning of the year than we do second semester. But I suspect some of you are going to do great with the table questions. So I don't want to give you a worksheet making everybody practice 20 of them. But a few people are going to struggle reading the tables. So some people need to do 20 questions before they start to get the hang of it. And Khan Academy kind of gives us that flexibility. If you know it and you can do it and you can get 4 in a row right at the start, then you're done with that one. And I guess if you don't have your Chromebook with you today, you'll have to add this for homework. Is it showing up for y'all in there? Okay. That's what I thought. Sorry, give me 2 seconds.
Where are you going to link it in Classroom?
If you go to you just go, well, I don't have it set up. I had it set up one this morning, but it was so slow. And I thought I set up this one, but. So give me just a second. Second period. Okay, if you go to Google Classroom, that you should have signed up for last time, I am putting it in the announcement. There should be a Khan Academy link. Click that, say that you're joining the class, and if I was you, I would make sure I was signed into my school Khan Academy, but sometimes students do, sometimes on their personal Khan Academy and sometimes on school, and then they get confused. try that.
Does it still need to be assigned, I'm guessing?
Yeah. Okay, let me see if this went to the right one. Sorry about this. I thought I had it set up before class, but it tagged it to the wrong class, so. Okay, I think it should show you the two now when you get in there. So Google Classroom, in the announcement, there's a Khan Academy link. Click that. It will ask you to join the class. Just say yes, and then you should have access to the 2 assignments on there. Please make sure you do your scratch work on that piece of paper that I ask you to number as number 6. That way, if I need your scratch paper, I can ask for it. But also, as you get to things and you realize, man, I've made the same mistake 3 times, and you write yourself a note, you've got somewhere to put that and somewhere to put that in your binder where you could actually find it in a few months. So,
How much time do we have in class to work on this?
you have the rest of the class. So that's 20 minutes.
20 minutes.
Yep.
I'll finish 4 and then go to 6.
Yeah, so on our agenda is always tentative. So I was hoping to start number 7 with you today. We won't have time to do that, but that's okay. Just make sure you have it numbered, and I will ask you to get it out for bill work next time. Okay. Does anybody having any tech issues getting in the Khan Academy before I come around and help with math? I need to make sure everyone sees the work.
Is this one, because it 4
Yep.
lose 8? Okay.
Yep, perfect. Especially on the conjugate questions, you might want to look at the one I did for you on your notes and use it as a guide the first time or two. Again, I am passing back your homework to you. Just put it back in your binder. Yeah. Arthur. Lily. Eddie. Logan. Noah. Emma. And Lauren.
Yes.
LN1's not E.
Oh, it isn't? What is it then?
So you need to remember natural log means log base E. So this is saying E to what power gives you E?
1.
There you go. The natural log of E is 1. One other thing you need to take note of on the Khan Academy questions, as you miss one, or if you miss one, when it says in the bottom right, like, try again or something, there is a tiny little link there that says get help. And so if you click that, it'll show you the steps to the question, and you can compare it to what you did and see where you went wrong and what learn from your mistakes that way, instead of just trying over and over again to do the same thing. So if you miss one, I would figure out why you missed it, and then I would probably start over.
But this question was asking element 1. So would that be 0?
That would be 0. Yeah.
Okay.
Sorry, I didn't remember your question. Y'all got any math I can help with on this yet? Also on these, you don't have to copy the questions down for me. Just if it helps you, I just want you to have the scratch work in your Yeah, when y'all do the scratch work, you don't have to copy the questions down to your scratch work. I will see your score. You guys doing okay? Anything I can help with? Doing okay? Any comments, any questions I can help with? Sorry, I have to bug y'all quite a bit at the beginning of the year until I can trust that you'll ask questions when you need to. So, y'all have math questions I can help with? Okay, so you should have a point at -2, 1. You got that. The limit as x approaches 3 should be 1. You got that. H of 3 should be undefined. You got that. And then, well, I gave you a chance to ask questions, so. But yeah, if you finish this, I can get you half your points back. This is saying that the limit as x approaches -2 from the left needs to be less than the limit as x approaches -2 from the right.
So this would mean like, this is decreasing, this was increasing or something?
No, it means they're gonna be second. Like right now, your limit from the right is 1, right? They want this one to be less. So look at it first. -2 from the left, something less than 1, down here.
I just think that they just put it as a reliable.
Yeah. And then this needs to be constant here and decreasing everywhere else. So you know, you're going down here and down here, not flat there. So next time, make sure you ask, so that doesn't happen. Also, I have the solutions posted online, so if you got stuck on that one, sometimes that's enough to get you up. Okay, comment, any questions I can help with? Girl, children, okay? Back here, is there 1 or 2 I can help you with? Okay, we still got about 8 minutes of class, so about 4 or 5 minutes from now, I'll remind you where you need to be before next class.
first one, with the table estimating?
No.
Okay.
So, like, if it was one of those conjugate type questions and I asked to see your work and you had no work, I would know something was off because
Yeah.
nobody's doing all that in their head. But the limit from the table, if you know what you're doing, yeah, you can look at it and get the answer without showing steps. So, I understand the difference. This wasn't enough work to keep you busy.
Oh, sir.
I'll have to give you more next week.
I guess.
So, I might just be missing something here, but this is saying that this turns into -4 times x minus 4. And I'm just a little confused, because if we factored out 4 for each of these, on 12 would be 3.
Okay, but,
So I'm just a little, I don't know how we got from this to this.
okay, so they're saying that this is 4,
Mm-hmm.
and if you distribute this negative, that's a plus 12.
Mm-hmm.
So they're saying 4 plus 12 is 16. They're skipping a step here. And then this is negative 4x. So they've got negative 4x plus 16, and then they factor out a negative 4.
Okay, that makes sense.
Yeah.
They just kind of skipped the work in there. Okay, we got about 4 minutes here, so let me verbally say again what your homework is, if you have any, what you need to be worried about, what you don't need to be worried about. Okay, so I'll have to adjust the agenda on here. Actually, the homework part is correct. So, the 2 things I'm going to expect you to have done before class starts next Tuesday, because I won't see you tomorrow. Tomorrow is an A-Day. Is I want you to have 100% on both those Khan Academies. Feel free to do it as many times as you need to. And I need you to have assignment number 4 done. That's the one we started last class, and then I gave you like 15-20 minutes to work on, and I did a few more examples for you. That was the factoring. Well, you should have it numbered in your binder, so you should know what I'm talking about. So, number 4 and number 6 are the 2 that you need to have done before class starts next time. I will pick up number 4, and number 6 I'll have the grades in Khan Academy for you. Now again, you've got a weekend between you. You should know as a student, if you're the type of student that forgets that type of stuff over the weekend. If that's the case, make sure you write it down or go back and check the agenda this weekend. It's on the top right of our class website that you have bookmarked.